All right, good day. Thank you for paying attention, I guess. It's the second day. It's a little bit slow. It's not so sunny. What I want to talk about today really quickly is a particular set of problems that we're tackling at PlanOS in terms of geospatial sensor data focused on the real world, as we like to call it. So as soon as you step out of indoors, you go out and start looking into oceanic or atmospheric data, you start looking into weather and climate, things get a little bit more trickier. And one of the problems that we're helping today to solve for our customers is how to find and access their own data as well as public data as well as commercial data. And PlanOS is building a search and discovery and an exchange platform, which really enables you to crawl the entire either your own network or an open network to identify data that you have in your kind of disparate organization without actually moving the data itself. And we do that by deploying crawlers and downsampling data to give you data previews until you actually need or know what you need to do with the data. Either it's data fusion, you want to access the data programmatically, you want to build your domain-specific applications, and so forth. And it's an interesting problem to deal with, mainly because we started out with a completely different focus, which was in the oceanic and atmospheric data domain. 3 years ago, we launched a service called marineexplore.org, which today is one of the biggest footprints on the web for public ocean data. And we collaborate with 35 organizations. We have 43,000 data streams coming in on a daily basis. We deal with, from everything from point data to raster data to multidimensional arrays to terrestrial features, all of that in one data platform. And in this experiment, we dealt a lot with the traditional ways how to ingest data, manage data lineage that a colleague from Teradata was talking about. A lot of these kinds of problems like provenance come into play. And you can't really do much without metadata, especially in scientific data world. This older platform, which today we call it PlanOS 1.0, was really mainly built in Python and was not really something that can scale beyond what we really have. Mainly because any new data source that we would collaborate with, or organization would collaborate with, meant that we needed to go and write a new script. We needed to actually integrate the data. We actually host all the data that we have. And there's so much data out there, and even though the numbers may seem big, when you talk to a user, they ask, "Oh, do you have like pH data in Prudhoe Bay, Alaska?" Then you say, "No, sorry, I don't have it." But somebody has it, and we intend to make it discoverable at least as much as it is possible. And there are a lot of repositories. In fact, when you look at only OpenDAP repositories in the scientific data domain, there are over 2,000 of them available. So there are a lot of logical data sets that are not available today. And that's one of the key things that I wanted to talk to you about as an example. So there's a big organization called NOAA, which some of you may have heard of, and they have a challenge, which is how to make NOAA's large-scale weather and climate data easily discoverable and machine-readable. And there's a lot of data that they have in-house, which has never been made accessible, even though that they have like reanalysis products that they're creating in-house. But really, like, providing real-time weather and climate data in the best possible way in any point in time that you're interested in, up to a reasonable level, is something that hasn't been done. And NOAA's challenge really is that they have tens of thousands of devices deployed, not only in the US, but all over, actually. The United States invests the most into data acquisition from, so to speak, the real world. This information is critical for government and industries, but the problem is that a lot of this data is scattered around, so it's not really easily accessible or discoverable. There are like FTPs and flat files, and you have thread servers, which is OpenDAP, which is technically an API, but really this is not like a coherent service that you can just consume as an industry or rely on. So you have a lot of overhead as an organization if you're in the weather industry, for example, or oil and gas, or shipping, or any industry that is exposed to weather, let's say this way. The data that NOAA has today is estimated, what we know is about 20 terabytes per day. Today, there are some numbers in terms of OpenDAP. There are like 4,800 NOAA data sets. With OpenDAP, I mentioned 2,000, so I mean, I still have it in my head somewhere when we did the initial test crawling. And then for the ISO 19139, we have over 26,000 in the world, so to speak, of NOAA available. And so what's wrong with how it's done today? So, and rather talking about like how difficult and how the different technical interfaces have been set up, I would just say that basically today what we see is that domain experts cannot do their own work. So you start out with a young, passionate, enthusiastic specialist, and then at the end you get this really not bored but really tired middle-aged professor that really has become more of a mediocre programmer than an excellent scientist. That happens all the time, and in a way that's kind of inevitable because without knowing the domain you cannot really work with that data, and so that's how it happens. Technical challenges. I must actually say why I'm saying all this. NOAA has announced a project called the NOAA Big Data Project, and the idea is that they have partnered up with 4 big forces in the industry: Amazon Web Services, Microsoft, IBM, and Open Cloud Consortium, who I believe we have a talk here yesterday. And the idea is to work with those partners to bring NOAA's data to the cloud. And PlanOS is one of the partners in the AWS Data Alliance. And so with that, here are a couple of technical challenges that we need to deal with as well as NOAA does. I mean, everybody in this project, which is quite interesting, in fact. So you have to really store, process, and index spatiotemporal time series and area data. Everything starts mostly from some weather-related data, naturally, because that's something that people are the most interested in. You have to process a lot of data per day. You have to transport the archives from NOAA to AWS. You need to start disseminating real-time data at the latency of minutes, especially when you talk about weather. People are really interested, and the more devices are being introduced in the world, which is something that we started from. In fact, our project, our company, got started from one single data buoy in the Gulf of Finland, where we tried to understand how the fish move by measuring phytoplankton concentration in a vertical column. And so, there are obviously historical data sets that you're interested in, but this is the technical challenge if you really are interested in real time. There are lots of data sets, so you need to be able to index those. And then on top of that, you need to provide a uniform API to be able to access all this. So this is probably something that NOAA itself couldn't have done, so they launched this kind of a partnership. In an interesting way, a lot of people wanted to help. A lot of people are interested in the data itself, whereas NOAA is responsible for actually, acquiring this data. Potential solutions that are considered is really, very easy to say, hard to do. Index spatial, temporal, and semantic metadata, all NOAA data. indexing downsample remote data sets, which we intend to acquire over OpenDAP, at least in the first run, and then we'll see where we go there. Then slice this data up into chunks. That way it's going to be much easier. And then provide on-demand infrastructure for analyzing this information. So as I said, we partner with Amazon, so this is where we stand. This is very much in the early days. It would be very interesting to come back in a year and say how it all goes or went, or what's the status. A couple of thoughts that we have also thought about is what would make this even better. So there's an idea of what if we could figure out a good data compression algorithm for these different data types, so that we could actually just make all this much easier for us as people that need to extract the data and then provide that to people. Not all data is created equally. Not everybody wants the same data, so it would be very interesting to do so. Then there's this BitTorrent-like data dissemination idea, of course, mainly because ease of use. Sending pre-filtered data to consumers, as I mentioned earlier, somebody wants a pH in Prudhoe Bay, Alaska, or whatever you want. You really are interested normally in a microscopic amount of information as a user, but as a provider of the data, you need to really have everything, sort of like the everything store. Then we really need to figure out ways how to how to do computations next to the data itself. Mainly, it's easy to imagine how you can draw a box diagram on it, but how to really do it, we're not really sure yet. And then another idea, which is kind of popular among the scientific community, is what if we could write some scripts, allow people to write some scripts right inside the browser in a service, or just like some sort of a SQL interface. And where it all comes down to is that, as you can see here, you can see that there's a bunch of data on the left-hand side there, which we would go ahead and crawl and index and enable you to just get an understanding what is the data that you actually have to begin with. And then there are a lot of data that are commercial, data that is sold by companies that provide value-add services, whether using this public data or acquiring their own data. And then there's the enterprise data. So all this comes together, and we're working with big corporations and service companies that serve these big corporations that deal with a lot of real-world assets and really need to have a grasp. So what we really want to do is to provide a lens to the real world so that you know what's going on and you can react immediately. Whether that's some sort of a natural disaster that you want to be ready for, or you want to plan for something, or you want to just be the most efficient company as you can be. So that's, I think, it from my side. Thank you.